Okay. Let's do number 9. So number 9 is cosine of root x. That is definitely a function inside of another function. So what we're going to do is derive the outer function first, which is definitely cosine, and we're going to leave the inner function alone. So that is negative sine of root x. Okay? And then we're going to pretend like that cosine wasn't there, goodbye cosine, and derive what's left over, the root x. And we're going to multiply that. We chain it on to the end. 1 over 2 root x. Okay? And technically what that really is here is we could, well, let's write equals. You can leave it like that, but that's really just one big fraction, negative sine x over 2 root x. It's the same thing. Okay, again, the first thing's not wrong. That's fine to leave it like that for right now, but when we start simplifying them, that's what you're going to do. Okay? All right, number 10 are the same two functions, but I've reversed their order. How sneaky. So the outer function for number 10 is the square root function, and the derivative of a square root is always 1 over 2 times the square root of whatever was inside of it. Okay, so 1 over 2 root cosine x, not 1 over 2 root x, but the cosine goes inside of that. And then you pretend like that square root wasn't there, because that's the outer function, and you derive what's left, and that's negative sine. How are we doing? You guys getting these? Some people getting these? Okay. Our test, guys, on derivatives might be one a long way, right? H going to 0, the limit definition of derivative. There's going to be a whole bunch of these, and I'm going to add in our new rules for like exponential, for the arc trig, for logs. Okay, but the chain and the quotient, all that stuff doesn't change. You cannot have the rules with you. No, you're going to memorize the rules. Yes. Yes. All right. Number 11. Probably not next week. Oh, no, we'll have a quiz next week on derivatives like this, okay? All right. Probably not Monday, maybe Tuesday. Okay? Like five or six derivatives. See how everybody's doing. Okay? All right. So, number 11 is the quotient rule, because it's a big old fraction. And the quotient rule says, write the denominator, derive the numerator. But the numerator is a function in a function, so that's the chain rule. So, we're going to derive tangent first. That's going to be secant squared, and the inside stays the same. Okay? And then we're going to multiply that by the derivative of what was inside of that, which is that 2x. Minus. We're going to leave the top, which is tangent of x squared, times the derivative of the bottom, which is secant x, tangent x. And that ridiculous fraction is all over the denominator squared, which is the secant squared of x. Okay? I know, right? That's what I got calculus. I told you, there's a lot of opportunities for good tattoo designs. That would look great. Yeah. Okay? For $100, you will tattoo something on yourself for the rest of your life. It's too cheap, dude. Okay. Yo, does that make sense? Everybody feel okay with that? No questions? You can't put, so you said we have secant times the secant squared. Like, you can't put those together to make secant cubed because their arguments, the thing inside of them, is not the same. Make sense? So we have to, that's the best we can do. We can actually cancel out one secant, but we don't need to worry about that right now. Okay? Alrighty. Number 12. Let me steal this thing. Okay. Number 12 is the product rule. Is our big rule there. So we derive that. We'll derive the first. We'll leave the second. So the first thing is secant of 8x. Let's make sure everybody understands. This is not multiplication there, right? It's not secant times 8x. That's different. That would look like this. Secant x times 8x. That's the product rule with secant and 8x, okay? This is 8x plugged into secant. So when you derive secant, which is the outer function there, okay there, Chief, you're going to get secant tangent, but the inside stays the same. Okay? And you multiply that by the derivative of what is inside of that, which is 8x. So we derive that and get 8. All right? And you can put the 8 at the end, but normally they just put the number at the front. So 8 goes up there like that usually. If you have it at the back, it doesn't really matter as long as it's multiplied in there somewhere. All right? For right now. And we multiply that by the second set of parentheses. Plus, we're going to leave the first thing and multiply by the derivative of the second thing. Come on, pen. And that's that. Not too shabby. Okay. Let's talk about number 13. Hold up. What's up? You all right? Okay. Number 13. It's still 13 and 14. We'll take these both down. Then we'll come back up. Up, up, up. All right. I'll do 13 right here. No 14 underneath of it. 13 is just one thing raised to a big power. So that the derivative here is power rule. Okay? Anything to the 7th power, you don't have to derive 7th power. You multiply down to 7, take 1 away from the 7, make it a 6. So b prime of x is 7, come on, man, times 5x squared, 3x cubed, minus 10x to the 6th. Do you see how I didn't derive the inside thing? I just derived one rule, the 7th power. Also, if you don't want to do the chain rule, you do have the option of multiplying this thing out 7 times and just doing power rule. Yeah, that'd be fun. Don't do that. Yeah, don't do that. And we're going to multiply that by the derivative of the inside. Easy enough? Okay, so, and just to write this out here, in general, our rule for deriving, this isn't going to be super nice math notation, but you could think like this. Anything to a power, right? If you drive anything to a power like that, will be n times that, come on you, times that same exact thing to the n minus 1. That's a question mark. Does that make sense? That's power rule. And then times the derivative of whatever was sitting in that power. Okay, that's just the chain will happen. Okay? And then 14 is, that's just to the 1/3 power. So p prime of x becomes, everybody watch this magic, 1/3, and it's going to be cotangent of x to the 4th to the negative 2/3 power. So you can write that out right next to it, but because it's negative and I'm thinking ahead, I'm just going to move it right down to the denominator. So it's going to be cotan x to the 4th to the 2/3 down the bottom. Okay? That's deriving the 1/3 power. Now we derive the next thing, which is cotangent. Okay? That's the next outermost function. The derivative of cotangent is negative cosecant squared x to the 4th. Then we take away that cotangent from up there, so we derive the cubed root, go by cubed root. We derive cotan, go by cotan. Now we got to derive x to the 4th. Cool. And there's not much you can do with that. You can put that all as one big fraction if you wanted to. For right now, this is totally fine. Right. And then last two. Oh, 16 looks stupid. I don't want to do 16. 16 is not bad. It took me a little bit of work to get that pumpkin in there. All right. You think Word just has that pumpkin in there? No. I had to search for that. Okay. Ready? We're going to do 15 right here. Q prime of x is equal to, we're going to, I was getting fancy with these, write the denominator, which is that, and multiply it by the derivative of the numerator. But oh no, the numerator itself is a product, so we have to do the product rule, which says derive the first, 2x, times the second, plus leave the first, derive the second. Does everybody see that that is just the low times the derivative of the high? And the only things we're actually deriving here, gang, are the functionals I gave you, the power rule and the trig functions, basically. The product rule just tells you where they all go, where each piece goes. Minus the numerator, which was x squared tangent x, times the derivative of the denominator. But the derivative of cosecant of anything is negative cosecant. Leave the inside alone. We're not touching that. That's just still there. And then times the derivative of what's inside, which is root x. When we derive root x, y'all know what root x is. This puts a 1 over 2 root x. So you can put that at the end, or you can just put the whole thing over 2 root x. That's what that does. Okay, and to be fair, this is much more complicated than anything you'll see on the AP test. All right, this is just me giving you a bunch of weird stuff to make sure you see how the rules play together. We're not done yet, right? This has to all be over. And I know it's ugly, but it doesn't matter. We're just going to write it out. Cosecant squared of root x. Okay? A couple of things, just things that I see kids do poorly. Guess what kids want to do to the root x's over here in this piece? I see kids cross them out sometimes. That makes sense? Like if something's in a trig function, you can't get to that. Okay, so this doesn't really simplify at all. That's just it. Okay, and 16 is really just, without the pumpkins, is just secant of x squared over 3x cubed minus 4 to the 1/3. Okay, that's not the derivative, that's just what that is. Okay, so z prime, using the quotient rule, is write the denominator, 3x cubed minus 4 to the 1/3, times the derivative of the numerator, which is a secant. So when you derive that, you're going to get secant tangent. And then we multiply that by the derivative of the inside. So that's low d high right there. Then we're going to write the numerator, which is secant of x squared, and derive the denominator, which is power rule. That's something to the 1/3 power. So you're going to get 1/3 this thing to the negative 2/3 times the derivative. So the multiplication, the chain rule is always on top. It's always in the numerator. So make a big parenthesis. So this whole fraction times 9x squared. You don't want that. Get that? That's high D low. And that's all over the denominator squared, which takes that 1/3 power and makes it 2/3. That's it. There's a lot going on there, but that's the end.